Good afternoon, everyone. So happy that you could all join me here. It's a bit weird standing this high up because now it feels like I'm looking down on all of you. That's unintentional. You all look like cool people to me. Before we get started, I want to do some quick questions. So just a show of hands. Who here is a consultant who works for customers, writing software for customers? Most of you. Awesome. Who of you have never worked with Dapr? Okay, let me change the question. Who has worked with Dapr? A couple. Okay. Aspire? Who has worked with Aspire? Okay. Yeah, you have, I know. You just gave a talk about it. Okay. Cool. So I'm a consultant myself as well, and I have been building a project using Aspire and Dapr. And I have opinions about that, and that's why I'm here. Who am I? My name is Nico. I'm a consultant from Belgium, where I work as an application architect at a company called Inetum. I'm Microsoft MVP in developer technologies for the past 10, 11 years, something like that. I run a local user group as well, involved in some conferences. In my spare time, I like to brew beer, play some guitar, ride a bike, not all at the same time. If you want to follow me on socials, that's down here. Should you have any questions for me after the talk, you can find me in the hallways. If you want to reach out online, that's the way to do it. All right. With that said, let's set some expectations. The things I'm going to talk about today, they involve this project that I'm currently still working on together with my team. A lot of the things I'm going to tell you are decisions that were made out of necessity because there were certain restrictions, things that we could do, things we couldn't do. So don't take what you will learn today as the only truth. It always depends on your customer, on your project, on whatever requirements that you have. Also, the way that we are doing it is not the only correct solution. I don't even know if it's a correct solution. So far, it seems to be working. So take this with a grain of salt. Do with it what you want. I'm not here to tell the whole truth. So, as for the project itself, I can unfortunately not name the customer that we're building this for. Because I asked and they said no. I can also not talk about the actual project, but what it does about the functionality, because I asked the customer and they again said no. What can I talk about? I can talk about the requirements, technical requirements that we had, the restrictions that we had, the technology that we used, and the problems we ran into. And that's what this talk is mostly about. And it all started with a bunch of decisions that our customer made. As for timeline, I'm getting to that, but this kind of started beginning of the year, and I'm involved since February. I was not there during pre-sales. I was not there at the start. They pulled me in after a month to expand the team. Talking about the team, I have no slides about that, but it's quite a big team. We're about 25 people, of which 10 are developers. Then there's analysts, there's QA, there's project managers. There's a whole bunch of people. And of course, there's customer as well. For the consultants here, have you ever thought that our job would be so much easier if there was no customer involved? Start of the project. Some decisions were made, like where will we host this thing? And this thing would be about 2 APIs and 2 front ends, something like that. Where will we host this? And customer went, I don't know, either in the cloud or either on-prem, one of those two. Okay. So what do you want us to use for infrastructure as code? Let's do Terraform, because that way, if we choose on-prem and then we choose to go cloud, then we can reuse those scripts. Yeah, that's not how Terraform works. But okay. Technology stack, at least some sane choices. We are doing ASP.NET Web API in the backend. We're doing Blazor in the front end, which was fine for them as long as it was Blazor server. God knows why. Authentication, authorization. Actually, right before this call, right before this talk, I had a call about that one. They have an on-prem identity server 3, which we need to use. We're not using it yet because it's on-prem and it's identity server 3, but eventually we'll have to. And this is where things get really interesting. We are using Blazor to build the front end. This customer has a lot of internal projects, some internal facing, some external facing to their customers. They've always been a company that does .NET. And now they've chosen to adopt Blazor as a new front-end framework. Really cool. And they want to keep a style throughout all their applications. So what they did is they sourced a company to build them components, front-end components that we have to use. So that's our first dependency. We are dependent on a different company to build our front-end components that we needed to use in our Blazor application. Yeah, doesn't sound too bad, except we were the very first project to use those components, and they are not all that stable. But again, so that's some delays in time, because every bug we need to go back to them, they need to fix it, we have to install a new version and go back and forth. It's a dependency. There are some more dependencies. Eventually we decided, or they decided, to go with Azure, and we were going to do container apps. So they asked yet another company to set up a CCOA, Cloud Center of Excellence. And they are doing the entire cloud setup, and we can just push some resources to it and push our application. So in the end, to make a short story long, we had about 18 different dependencies, different companies that we can talk to depending on what the issue exactly is. So that doesn't help. And that is this entire explanation just to show you a bit at why we made certain technological decisions. So we decided to go with Dapr because when we were supposed to start development, we were still unsure about the hosting. Will it be Azure? Will it be on-prem? We didn't know. What we did know was that at one point we were going to have to do storage, file storage. We would probably have to do messaging. We would have to do some Redis caching. But not knowing where, that would mean if we make the wrong choice here, we would need to do a lot of refactoring once the decision was made. So that's why we decided to go with Dapr, because Dapr is an abstraction layer on top of all these, which makes it easier to move from one thing to another. That's the sole reason we chose Dapr. In the end, we were already developing when the decision was made, and we decided just to keep Dapr in because it works for us, and there's no reason to take it out. We decided to go with .NET Aspire because it made our inner development loop easier. Now, bear in mind, we are talking about February this year. .NET Aspire was on preview 2. This is where we started the project. We convinced our customer to use preview technologies, and we had so much fun with it. Having permission to use .NET Aspire Preview 2 also meant that we needed to use the Visual Studio 2022 Preview Edition because it was not working in the normal stable one. So there we were, a team of 10 developers working with Visual Studio Preview using .NET Aspire Preview. This is the timeline. In January, the project started. In February, the team grew, the developers came in, we started working. Everything was set up with Preview 2. Everything was up and running. The devs were all onboarded. A week later, here's Preview 3. Okay? Upgrade was not easy. And that's about this common theme across these previews. Upgrading to a newer preview version always had breaking changes. But that's to be expected. You're running beta software after all. March, preview 4. Again, breaking changes. April, preview 5 and 6. 2 previews in 1 month. And if I'm not mistaken, but I would need to check, I think from 4 to 5 was really, really a tough one to upgrade. A lot of breaking changes. Because the Aspire team was still figuring out how they would name things and architect things, and so they were changing a lot. And then in May, there was preview 7 and the G8 had built. General availability of Aspire was there, so finally some stability. We could move back to normal Visual Studio. We had some stable versions to work on. We spent a lot of time on those upgrade paths. Some of them, and I believe it was between 4 and 5 or 5 and 6, we spent 3 days to make it stable again, to go through all the breaking changes. And upgrade the entire team. Because upgrading did not just mean installing newer NuGet packages, you also had to update the workload, because Aspire is a workload on your machine. Then in June, we finally got the green light that it would be Azure. And here are some temporary landing zones while we put a CCOA in place. So we finally could deploy. And you've probably all heard about Aspire and seen the getting started demos, right? So you know AZD up, everything spins up into Azure, and you're golden, up and running. Except that we were not allowed to do that because we had to use Terraform. So more about deployment further along in the story. But we had some Azure environments, so we started deploying, we started running, everything was good. In August, the CCOA finally decided on, here are the real landing zones. So we needed to redeploy everything into the newer environments, and this was done on the last Friday before I went on holiday. It was me who needed to do this. I was done at 5, closed down the laptop, went home, done. And everything actually went kind of smooth. And we thought, this was it, we're done, landing zones are up, environments are up and running, until last week they told us that they will need to be replaced because they got the naming wrong. They want to rename the environments, which means deleting all the resource groups and starting over. So yeah, that's where we at right now. Now, that's just story. I needed to fill some time to get to the 50 minutes, that's why. This is the basic architecture of the application. As I've mentioned, 2 backends, 2 minimal web APIs, 2 frontends, 2 times Blazor. Why 2? Because there are 2 applications that kind of need to work together. One is an internal-facing one that will be used by about 4 to 5 people. And that application is used to configure everything, to prepare whatever the other application needs. This is hard to explain without going into too much details. The second application is public-facing. Everyone can reach that, and that can use the data that was prepared on the internal one to fill out some forms. During architecture phase and pre-sales phase, they decided that having 2 databases, one for each, and keep them in sync was too expensive. So we chose to have 1 database. And this is a SQL Azure database. And that one holds 2 schemas. And there's data from the internal application in the internal schema, external application in the external schema. And we're keeping data in sync between those 2 schemas, because it sounded like a good idea at the time. Then there are a couple of external APIs, and one of these is the Identity Server 3, right? These external APIs are hosted on-prem, are completely out of our control, but we need the data that they provide. These are the protocols that we're using. Obviously, between the APIs and the front ends, we're doing REST calls over HTTP. Some of these external APIs are also HTTP, some are gRPC. For the gRPC ones, we have internal NuGet packages that host the proto files, so we can easily generate the clients for them. That works all works pretty well. As for hosting, those are on-prem. Everything else is in Azure. Spend way too much time on animations. The 4 applications, so to speak, two backends, two frontends. Those are all in Azure containers. The database is a SQL Azure database. That was also something that they changed because in the beginning that was also an extra container. Now it's SQL Azure. And then there's Dapr integration. And for those of you who don't know Dapr, Dapr works with the sidecar pattern. This comes straight from the Dapr documentation websites. Dapr is a portable, event-driven runtime, makes it easy to build resilient, and so on and so on and so on. Basically, it's a sidecar pattern, meaning that your application runs in a container, and every container that has a sidecar has an extra container attached to it, and that's the sidecar pattern. In Dapr, that means that whenever we take a front end and make a backend call using Dapr, the front end actually makes a call to the sidecar, saying that, hey, I want information from this specific resource. And the resources are named, they have a name. So my front end says, I want something that's on a resource with that name, has that to the sidecar over HTTP. The sidecar contacts the other sidecar over gRPC, and he knows that this sidecar has the name of the resource that it wants. Sidecar fetches the data and it goes all the way back. So a few extra hops. But since this is gRPC, the overhead that you get from those extra hops is limited. There, of course, is an overhead because you're doing extra calls, but it's a bit more limited than you would think. But why would you do this? In our case, as I have explained, abstractions. You abstract away the underlying platform. Take, for example, file storage. You can go to an on-prem file share if you're using on-prem Kubernetes clusters, or you can go to Azure Blob Storage, or to whatever it's called on AWS, and so on and so on. And you don't need to change your code. Your code stays the same because you're using the Dapr APIs that are abstractions. What you do change is the configuration that in a YAML file says what the underlying implementation is that the abstraction will use. And to show you a bit how this works in .NET, let's walk to a quick demo. I will just start a new web API project. Sure, why not? Create. So just a simple blank API, and then a new project. That's a Blazor web app. Next, create. Very complicated situation. Just to show you how I'm doing all this, there is an extension, something Dapr. There we go. There's an extension by Microsoft called the Visual Studio Dapr extension, and this actually lights up a bunch of Dapr functionality within Visual Studio. Because Dapr is not only for .NET, you can use it wherever you want, whatever technology that you want. So there's also very limited integration to the IDEs. And to tackle that a bit, they made this extension, which they didn't talk about all that much. All right, for the rest, what else do I have? I have Docker up and running, and Docker has 3 containers. And if you set up Dapr correctly and you do Dapr init as a command, these 3 containers will pop up, and this is what the Dapr runtime needs to do his thing. Now, I have 2 applications here, a front end and a back end, and I want to use Dapr to launch these 2. What I now can do is right-click my solution, go to Add, and use the Dapr run file. And this comes from the extension. Now we have some YAML, because we all love YAML, right? this is what it generates. So what the command does is it checks your solution. It checks it for all executable applications in there, and it generates the YAML file based on what it can find. For example, we have the Blazor app, we have the web application 1, which is the API, I assume, and then we again have the Blazor app. Because this is new Blazor, which has a server-side project and a client-side project. Now, if I run this, that will just work thanks to the extension. But basically what you need to do is open a command line and go dapr run -f dapr.yaml. Then it will take the YAML file, it will build all the applications that it needs, and it will actually start running the application. So as you can see here in the output, everything is running now, but nothing pops up automatically. There is no debugger attached, and so on and so on. And this has been the Dapr experience before the extension was a thing. And even with the extension, it's still a bit more involved than it should be. So that's just a quick lap around Dapr. And that's why we came to the conclusion that Aspire could help us. Because, and once again, the explanation of Aspire from the docs, Aspire has Dapr integration and takes away the pain of doing all the configuration. It does it for you. It automatically generates it. And you can just press F5 and everything will start running and debugging and so on. With that, let's jump to a bit better prepared demo. So this solution kind of mimics the application that we've built in the sense that it has the external application with a backend and a front end. It has the solution folder for the internal application, but it's not quite there. And it has the Aspire app host. I've done it this way so that you can clearly see the structure of solution folders that we use in the actual project. Because there are some issues coming from that as well. All right, the app host is set as startup. Let's launch this. And here we have the beautiful dashboard. And of course, I don't know if you've seen this, but if you have Blazor in your Aspire project, then it automatically launches the front end as well, which apparently has something to do with attaching the debugger to the WebAssembly, or the WebAssembly debugger to Visual Studio, which is why they need to launch it at startup. Which was also kind of surprising because the early previews of Aspire didn't do this. And all of a sudden this started happening, and we thought it was a bug on our side. We spent a week searching for it. It was it's an unintended feature. Okay, so 2 processes running in Aspire. Who has never seen the dashboard before? A couple of people? Okay, so this dashboard is one of the features from Aspire. It shows you all the projects that you have hooked up in your Aspire, and I will show you the app host in a minute. From here, you can see the status of these services. They're both running right now. You can see the source. You can see their endpoints, and you can watch the logs and whatnot. So if you click View, you just see the console logs. You can switch here. You can see structured logs and all kind of tracing, open telemetry, and whatnot. So the app host is the actual starting point of Aspire, and here in the program is where you configure all your services. I have 2 services configured here, hence the 2 lines that you had in the dashboard. One is my API, which is called Presentation API because of reasons. And the second one is the UI, which is called UI because it is a UI. And this is a name that you give it. Now, let's quickly run this again. Meanwhile, while it's starting up, in the UI there is a weather page, and in the weather page, so this is Blazor, right? It injects a weather API client and it gets the weather, the typical demo that you get from all sort of templates within .NET. The weather API client is this. It's an HTTP client that fetches JSON from an endpoint, and the endpoint is the weather forecast endpoint. Now, if I look in my minimal API, right here, here's the endpoint. It just generates some dummy weather forecast and sends it back. Now, why am I showing all this basic easy stuff? Because, again, in Blazor, we have this set as a base address. And this is Aspire's service discovery functionality. I don't need to know what the base address of my API is in order to be able to call it from my front end. Aspire will make sure that those two know each other. So I'm setting my base address as presentation-API, which is the name that I've given it in my app host configuration. Then in my UI, I've said that my UI needs a reference to my API, which is the object created here. And because of this, Aspire will inject the necessary information into the UI project, so we can do service discovery without needing to know the actual endpoints. Meanwhile, this is started up, so I click weather, and here's the weather. Now, why am I showing you this? Because this we'll come back to this in a couple of minutes, because Dapr does the exact same thing in a different way using the sidecar pattern. For now, let's jump back to here. So that was the external app, backend, frontend, presentation.api, and then there's the internal app, where we'll also add a web API that we will give the exact same name. Like this. Now, here in the wizard, you can enlist this automatically in .NET Aspire orchestration. The wizard has detected that this is an Aspire-enabled project, so you can automatically add it to it. So let's do that. So if you're wondering about the naming of the projects in this solution, those have been an endless discussion. And finally, we've settled on presentation.api for our backends. And since we're basically building two separate products, they have the same name. They're just in a different solution folder, which is fine, basically. But we ran into an issue right here. The project's namespace over there, this is an automatically generated list of all the different projects in this solution, so that you can use them to point Aspire to that specific project. This being automatically generated should mean that now we should have 4 entries, because we have the app host project, we have 1 frontend, and we have 2 backends, which makes 4. But there are only 3 because, well, this would be an identical name. And the code generation behind this does not know how to handle that. So that was an issue that we needed to fix. Luckily, the fix was as easy as going into the CSprosh file of the Aspire demo, or the app host, and add a Aspire project metadata type name, which you can all remember, right? And then this was the external API. Copy, UI can stay. And this was the internal API. Let's save that, go back here. If you look at the list now those two are here. So that way you can rename whatever gets generated here into names that you find useful yourself. So this was the external API, which now also means that we can we can do this now. And we can add both the projects. If I now launch this again, there's an extra entry in there, or maybe not because there's duplicate naming. And then Visual Studio starts doing this. Come on. Like that. While this is launching, is the font size big enough for the people in the back? Can everyone see this okay? Awesome. There we go. 3 items in the list now. Perfect. So with that, we had Aspire up and running. Next step is adding Dapr to the project. And to do that, I add a NuGet package to the app host. NuGet package is called aspire.hosting.dapr. So if you just look at aspire.hosting, you find a lot of stuff in here. And that's a bit how Aspire divided up the different resources that you can add. For every type of resource that you want to add to the Aspire thing, there's an extra package that you can install just to keep the packages a bit lean. We're looking for Dapr. Here it is. Install. There we go. Now, I'm just going to get rid of this one. With Dapr installed, we can now say with Dapr sidecar to our API, for example, and just name it presentation API Dapr. I can do the same for the UI. UI Dapr. That's it. With those 2 simple lines, my Dapr is configured, my 2 projects are added to my Dapr, and they will have Dapr sidecars. If you look at the dashboard now, you see 4 running applications. 2 of them are the actual projects running, and the other 2 are the sidecars, which you can see in the name. They have the Dapr right there. And they're also running Dapr.exe. If you run Dapr locally, it's not a sidecar container that's added to it. It's just a process that's running, a Dapr.exe process. And just like anything, you can go in the logs and just watch whatever is going on here. So what can we do with this now? For starters, now we have Dapr installed, configured, ready to go. We can go to our backend, to our front end, and add a NuGet package to that. And the package we need here is dapr.asp.NET Core. And this package comes from Dapr itself. It's apparently still installed. This package just enables Dapr functionality in ASP.NET Core project, right? Now keep in mind that if you look at the installed packages in my front end, there's only one. Oh no, sorry, because the filter is still here. There's a couple, but not that many, and none of them are Aspire related. So my projects that I'm using don't know that they are being managed by Aspire. They don't know that. Meaning that I can now just use the Dapr SDK and just start following along with the Dapr documentation to get what I want. What do I want in this case? I want my weather API client that uses HTTP client. I want to use this one to, instead of that, be a Dapr API client, which means I can use Dapr client like this. Is this what I need? No, go away. I'm going to need the same method here, like that, but instead of using HTTP client to fetch some stuff, I'm going to use my Dapr client to invoke a method async, and this is going to return me weather forecast data in an array. I need to have a get method. It's going to fetch it from, what's the name of my sidecar? Presentation API Dapr. There we go. From that sidecar, I need the weather forecast method without typos, preferably, and just pass in the cancellation token. Let's do it like this. There we go. Need to await this. Sorry? Yep. Thank you. Okay, so this does basically the same thing as we have here on the HTTP client, except it's using Dapr now. So we're invoking a Dapr method, we're doing a get call, we're going to this app ID, which is the ID of the Dapr sidecar. On that sidecar we need the weather forecast method, and that should be enough to configure the client. Now we just need to add the Dapr client to our services. Add transient and add the, what did I call it? Dapr API client. Add this as well. And then finally we go to the weather page. That's fine. We're going to inject this. And we'll do it like that. So with that, and maybe just to show you that this actually works, or hopefully works, I'm going to set a breakpoint in the weather forecast endpoint. We're building, we're launching, we got the dashboards, everything is running, life is good. Here we are. So what now happened is that my front end contacted its sidecar saying that I want weather information. This is the sidecar that knows about it. The sidecar contacted the next sidecar that contacted the service, and then they came back with the data. That's what happened now. Okay, let's do some housekeeping, close all the tabs. Open the program again for the app host. All right, so we got that. The next thing we needed was a database. So also something that you can define in Aspire. Yeah. Have some patience, Mike. So again, we need SQL, so we need to add the Aspire hosting SQL Server. Except if you want SQL Azure, then you need Aspire hosting.azure.sql. There we go. We give it a name, name being demo SQL Server. So with that, I have a SQL Server, and then I can add a database to it, give it a name. And what this will do is, if I now add it as a reference to my API, meaning that it needs to be more on top. Come on. With reference SQL, there we go. If I were to deploy this, then Azure Container Apps will spin up a bunch of containers, and SQL will be in one of those containers. Well, actually, if I spin this up, it will throw an error, which is also something we found out the hard way once we started deploying, because SQL Server name does not take uppercase letters. Just as Dapr sidecar names doesn't take uppercase letters, and a bunch of resources don't take uppercases, which we found out once we tried to deploy them. So we go like this. So again, this will spin up a container with your database. Should you want this as an Azure SQL or SQL Azure, you can add this method to it as Azure SQL Database. Should you want something, one option locally, the other option when you are deployed, then you can check builder.environment. Was it environment? No, it was not environment. Execution context, that's the one. Execution context has some properties, is publish mode, is run mode. The is publish mode, that means it's going to check all these things when it's publishing. So if you want to use Azure SQL when deployed, then this is the place to check it. If you want to use containers, also same. We are actually using this for application insights, I believe, to have a different application insights when run locally compared to deployed. All right, let's see what's next. Let's actually run this. SQL should show up. The thing that it does now is it's spinning up a container hosting SQL Server. As you can see right here, looking at Dapr, here it is. So the container is right there. Now, if I stop this, then the container spins down again. It's gone. Meaning that if I now start the application again, I get a brand new database and all my data is gone. So not that interesting. Imagine being in production and you restart your container and all your data is gone. Not good. So in order to fix that, we had to add volume to it. With volume, I forgot the actual values, to be honest. But what you will get is this will show up in your Docker desktop as a volume, and within here in your data you will find all your databases, and your volume stays even after container restarts. So that's where you can keep your data on your local machine. For us, for the project, we are using containerized databases for local development, and we are using SQL Azure once deployed. All right, almost through. Other things we did where we also used Dapr is we had the Dapr state store as file store, and we added this to the API. Why do we need this? Because we are uploading PDF files and reading those. So again, same thing. With this, Aspire will try to see where it's launching, and it will make an educated guess on what type of resource to deploy to. So in this case, it will just use local file storage. When deployed to Azure, it will use Azure Blob Storage. Now, for the sake of time, let's go have a look at this solution, but already deployed. Deploying an Azure solution means opening up your CLI, and this is according to the documentation, so this is how they're selling it. Opening up your CLI, do AZD up, after you do init, of course, AZD up, and everything spins up automatically. That's what I've done with this. This is the result of that. Meaning you get a container registry, you get an apps environment, you get a bunch of apps, even some log analytics and application insights if you want to. You get your identity, your storage account, everything's there. Just AZD up, you wait, you're done. Now, the interesting thing is, when you do this, it does not show you at first what's it going to do. It just says, okay, I got this. Everything deployed. There is no enterprise that will accept this. I can promise you that. Our customer would not accept this. Imagine making one wrong change and everything gets deployed and everything is broken. Even on your dev environment, that's just not the right way to do it. You want to see what your system will do first before applying it. And to see how we did that, let's jump back here. So, as I've mentioned, we had to use Terraform. We have a service principal. We have no direct access to the portal, so that's why we're doing everything through our pipelines using Terraform. And what we do is, we deploy to every single environment separately, of course. And these are the steps. So first, we execute a plan command, which means that Terraform will check its configuration and will check the deployed environment, and it will create a div. And that div is the plan. And what you see here on the right might be a bit small, but this is something that might be part of the plan. In this case, it will generate a new container for me. It's all, if you see in Azure Container Apps, you recognize these properties. Here's the actual container with the image that I've edited out. There's some environment variables there. There's an init container to apply the migrations and so on. Now, after the plan, it has a manual validation step, meaning that it will wait for me there. I need to click, I've reviewed the plan and I agree with the plan. And then it will apply. And once this is done for the dev environment, it will move on to the test environment, create a new plan, again wait for validation, so that we can know what it will do before it actually does it. Which makes more sense if you ask me. Now, one of the problems we had with Terraform is that it does not support all features. It's not up to par compared with the Bicep, for example, which is Microsoft owned, so it's up to par with what Azure can do. One of the things we run into is that we need our front-end containers to have session affinity enabled, which is a property that you cannot set through Terraform. So in our oh no, I'm getting to that. This is not a slide I was expecting. There we are. In our deployment pipeline, once everything is deployed, we use the Azure CLI to set the sticky sessions, which is the session affinity. So we have to do that manual step again because Terraform is lacking that feature. Going back to this one. So we build everything. We create the new containers. We push containers to the container registry. And then we execute this command that says to our container app, you have an update, pull the newest image or pull the image with that tag. We are tagging with the build IDs. And then Azure Container Apps will just spin up a new revision and everything is deployed. Once the new revision is up, it will spin down the old one. Meaning we would have basically zero downtime. if not for migrations that might break your backend or your older version of the backend. So we went through this. So to conclude, it's been a journey. It's been exciting. I strongly believe in technologies like Aspire and Dapr, and having the chance to work with them from preview version up until GA and further has been really interesting. I would do it again in a heartbeat because it was so much fun. But in short, .NET Aspire has really shortened the development loop and the onboarding. We went from onboarding a new developer in 6-7 hours to an hour and a half, and that includes installing Visual Studio. Git clone, F5, everything is up and running. For Dapr, there is native support in Azure Container Apps, and I did not mention this during the talk, but Dapr components have native support in Azure Container Apps. Dapr has a menu item in there in the portal, and it provides a certain abstraction layer over your whatever choice if they still need to be made. With that, I'm at the end of my session, about right on time. If you want to look at the code, it's right up there. There are two branches, a demo start and a demo finished. Obviously, the most interesting thing is in the finished one. Thank you all for being here. If you have any questions, come up to the stage or find me in the hallways or reach out online. Thank you so much.